So let us take our first step into an important concept, which is called memory addresses. Okay, understanding memory addresses is crucial because in the next lessons we will start working with pointers, and pointers rely on memory addresses. Okay, so what is a memory address? When we declare a variable in C, the computer stores it in a specific location in memory, which is the RAM. Okay, the memory I'm talking about, the RAM. Okay, each memory location has a unique number called a memory address. Think of it like houses on a street. Each house has its own address. Similarly, each variable in memory has its own address. Okay, so let us now take a look at how we can print a memory address. In C, we use the special symbol, a special symbol called the ampersand. Okay, or you can call it the address of operator to get the memory address of a variable. Okay, so let us start. Open your Visual Studio Code and then start coding. Okay, so here we have our integer called age. Okay, so this one we are going to store 20 in it. Okay, so after there we are going to try to print the memory address of age. Okay, but before we do that, let us get the value. Okay, so the value of age is okay. Then we are going to use the percentage d for integers, okay, which is the format specifier for integers, and then here we are going to have our age. Then after that we are going to print the memory address. Okay, but remember I told you the address. Let us use the address of age is, so the address of age is going to be, we are going to use the ampersand, okay, which is and here if we are printing the memory address, you should note that we use for the format specifier here we use the percentage p. Okay, like it stands for a pointer to a variable. Okay, pointer address to a variable. Okay, so the address is going to be, we are going to access it using ampersand. Use ampersand, then the name of the variable, like that. So if we save and then we open the terminal and then we compile our code, our file, and then we run, as you can see. So the value is 20, as you can see. So the address of here used os, or I made a mistake. So but of age is, or here I used si, but is, this is the memory address, guys. This is the memory address. It can be different because memory addresses change. Okay, it can be different for you. So every time we run, as you can see, it becomes different. Okay, so because they change. Okay, so let us take a look at memory addresses of different data types. Let us take a look at that. So here let us remove this code, this one. So here we have the integer, and this one let us name it x. So this one is going to be x, it is no longer age. So let us create a float y, and let us set it to be 3.14 for pi. Then from there, let us create another one for char, for characters, and then this one, let us name it to be c, and here we have that one. So from there, let us try to print the addresses. Okay, so let us use the printf function. So the address of a certain number is going to be, is of a certain variable is going to be the address. We use ampersand p. Then from there we are going to get the address of, then here we break the line, move the cursor to the next line, and then here we use ampersand. So for x we are going to use ampersand x, like that. So allow me to copy everything. Copy, I'm going to paste it 3 times. Then this one is going to be for x, this one is going to be for y, and this one is going to be for c. Then from there I'm going for the address of x is that one, and this one is of y and c, like that. Okay, so if we save and then we compile, then we run, as you can see, we get the address of x is this one, and the address of y is this one, and the address of 8 is this one. Okay, so we get that output. You should notice how each variable has a unique memory address. Okay, so every variable has a unique memory address. Okay, and these memory addresses are based on like the data type that they contain. Okay, so for integers, as we said, for integers, the memory address that is like where like 4 bytes are allocated, okay, for integer values, okay, 4 bytes are allocated, okay, for integer values, and for the character, and even for the front, okay, 4 bytes are allocated. But for the characters, 1 byte is allocated for it, okay, 1 byte, okay. So you should know that, okay. So why are memory addresses important? So these ones, they are important. Knowing memory address is important because they help us understand how variables are stored in memory, okay. They also allow us to use pointers, which are variables that store addresses, okay. And they also let us directly manipulate memory, which is powerful in system programming, embedded systems, and performance of critical applications, okay. So let us now take a look at how we can use memory addresses in real programming, okay. You may not use memory addresses often when writing simple programs, but when dealing with pointers, arrays, strings, and dynamic memory allocation, memory addresses become extremely important, okay. So let us take a look at that. So you can we started with printing out, okay. You can print it out, okay. You can get it out. You can also, so you should notice that before, because we saw how we can use them, we can just print them out. Okay. And we shall take a look at how we can use them, okay, when working with pointers, okay. So we can get, yeah, we can do that, okay. So that is it about memory addresses. You have seen how we can work with them, okay. How we can print them out, okay. How we can get them, okay, memory addresses of those variables. So in the next part, we shall take a look at how to use pointers, okay. How to go deep, how to work with dynamic memory allocation, okay.